So this is a very brief overview of kind of like how the PsyKyo engine works right now. Also, bear with me. I'm running this on my laptop, and I'm doing this, the game, and the PsyKyo engine. It looks like it's wanting to die. Anyway, I should be able to still give it a shot, though. But we don't have to spend too much time on this part, but this is essentially the PsyKyo engine code. It's been a while since I opened it up. Let me see if I can get to the tools. 1 second. So it should work right here. Boom. So I have a system, and we can get more into this later, but I can basically draw these boxes all over the screen. Move this out of the way. And I can resize them however I want, and then I can queue up things. So there's a little bit, it's a little bit complicated on how I do it, but like I can add a box like this. Well, I gotta click on this. I can add a box, and you might not be able to see that, but I can say there's 2 different ways that I can detect stuff. One, I can do OCR, so I can literally have there just be constant screenshots of these boxes. And that's how it works anyway. And every time there's a screenshot, it gets sent to an OCR inferencing microservice, and then it looks for text that I can expect. So like if I ever want to know if I'm in the campaign menu, I can make a box over here, resize it, you can make it transparent, and then I can take a screenshot, or I can just say, hey, these pixel bounds, if this ever says campaign in there, do this certain stuff, or change this game state. I keep a real long running game state. Anyway, and I can do that with anything. So I can do OCR, or I can do just raw pixel matching values. So like where that's really interesting and useful is like down here at this detect main menu. See, the only time this pixel arrangement is ever on the screen is whenever this main menu pops up. And I can take these exact values, save them ahead of time, and then I can, it's real inexpensive computationally wise to actually just check these raw pixel values. And right now I'm doing it on the CPU, and I can get I can do it about 3 times a second, probably a lot faster than that actually, but that's as fast as like the loop will go. But if we needed to, this can be CUDA accelerated, probably. But I have an spot for subtitles. But all it does is this essentially just grabs like a really big, it just keeps the game state updated. And let me see if I can find that. Sorry, there's so much over here. Yeah, so there's engine data. Let me try to move all this out of the way. And you kind of can't see it, but as things like, did a brutality happen? Who did the brutality? Who's won? What are the round win counts? Different game modes. So like this knows it's in the start menu. And what I can do is I can actually, and I get rid of some of these checkboxes. So it's not always taking pictures everywhere. I do that for efficiency. Anyway, this is a real basic example of kind of what I've got going on. But it can be used to feed lots of stuff. So like the sportscaster thing, oh, absolutely. We can feed it this game state to the LLM, and the LLM will be able to talk about things. And we can customize this to be whatever we want. And one of the cool things is I've actually tested this to work with for an LLM to be able to generate these configs. So you don't actually really write any code to extend to this. You edit these config files. So basically those pixel boxes are all in a config file. Everything's in a config file. And you can get an LLM to there's a couple ways that you can give it no context of the game, and it can come up with some pretty useful things to do, although that's as limited as you might think it is. But another thing you can do is I have some ideas with training. So if you just let the game go through a run through, and it takes the appropriate pictures and stuff, I think we can actually train a game to do this instead of someone having to manually enter in all these pixel boxes. Anyway, I have tons of ideas with this. I don't want to be too long. We can do a technical deep dive later. But that's how it works. Again, it uses OCR, and it uses this thing called pixel signature matching to keep a game state updated. and it's essentially like a person watching this. I wanted it to be like a tournament organizer who could tell what exactly happened in the game. Anyway, that is the PsyKyo engine. Definitely let me know what you think. This can be integrated into a lot of stuff, and I think it has really big potential in esports applications. And for example, I'm going to show you the patent in this later. There's tons of things that you can play off with this, or that you can play off of with this. So yeah, but anyway, that's the whole thing. Hope you like it. Let me know.